Today, I want to introduce you to anti-differentiation. So what is anti-differentiation? Well, in the past, we were given a function, f of x, and right now we'll just say that's 3x squared plus 2x minus 1, and we were asked to find the derivative of that, or f prime of x, right, which in our case would be 6x plus 2, right? Now, with anti-differentiation, what's going to happen is we're going to be given that derivative part, right? And we're going to have to find this part up here, okay? So let's try to do that with just this example. So we start with f prime of x equals 6x plus 2, right? And we need to figure out what this is. So what we're going to have to be doing is we're going to have to apply our differentiation rules, but in reverse, okay? So you're going to have to know them very, very well. So we have to think, all right, this is 6x. We're going to have to use power rule here, but in reverse, right? So what would be the reverse form of 6x with the power rule? It would be 3x squared, right? And you can test this yourself just by differentiating that. And then once again, plus 2, right? Well, plus 2, what do you take to get the derivative of 2, right? It would be plus 2x. Now, you can see that we might have a little bit of a problem, because we can see up here our original function had 2x minus 1 up here, but we can't figure out how we would get that minus 1 from this derivative, right? Because when we have the derivative, any sort of constant we had before vanishes away, so we lose that information. So what we're going to do instead is we're going to add a placeholder constant plus c. We don't know what this c would be, but we're going to add it there in case there was a constant, okay? So let's do another example. Let's do f prime of x equals 5e to the 3x, right? And we have to figure out, okay, what could we differentiate to get this, right? That's essentially the mindset you have to go into this with. So we have to think, all right, so e to the 3x, when you have an e to the 3x or anything like that, e to that power will always be in the problem. So once again, we can start with just adding this e to the 3x, right? Because the derivative of this is always itself. Then, with this part, we're going to multiply it when we differentiate it by the derivative of this power here. The derivative of this power here is 3, but we can't see any multiples of 3 here. So what this is going to be is 5 over 3, okay? And then, don't forget, we also have that plus c, okay, as that plus constant. And I encourage you to differentiate this yourself and see that we will, in fact, end up back there. Let's do another example. Let's do f prime of x equals x to the negative third, okay? Now, f of x equals, well, let's just start off by thinking about this logically. This is x to a negative power, to the negative third to be exactly. So when we apply the power rule here, right, what we would have done before is we would have taken out some power that would have been negative before and multiply it by this. But since we can see that this is positive, there must have been a negative there before. So we can start by adding that negative. Then we can think, okay, well, we had this we used the power rule and we subtracted by 1, right? So what must have been the power here before this? Well, the power before this must have been negative 2. So x to the negative 2, right? Then we can also see that this, whatever was in front of here, must have disappeared when we multiplied by negative 2, right? So then we can say this must have been 1/2 because that's the reciprocal of 2. So we can differentiate this, right? And we get f prime of x equals, well, we take down the negative 2 times negative 1/2 times x to the negative third. These will cancel out, and we just get x to the negative third. But then, don't forget, we had some sort of constant plus c, right? But then that won't matter for what we're doing down here because that'll just disappear when we differentiate it. So never forget that plus c. That's always very important. So let's do here. before we do the next problem, let me introduce you to something. So now we have some notation. We're going to have this. So this right here is our notation for the indefinite integral, right? You'll learn a little bit more about what that means later on if you're taking calculus. But so essentially all we need to know for right now is this right here is the integral sign, okay? This part right here, the function, that's the integrand, right? That's what we're taking the integral of, right? That's what we're anti-differentiating. And this part right here just means with respect to x, okay? So that's what you need to know right now. So then, let's do a problem of a different sort. So let's say we have f prime of x equals, let's say, sine x. And then we also know that f of 0 equals 0, right? That's another part of our original problem. So once again, what we want to do is figure out the function, right? So let's use that notation that we just learned, all right? And to figure out the function, all right, we're going to take sine x, that's our integrand, and then with respect to x, obviously, right? So now, once again, we just have to think about, okay, what can we differentiate that will give us sine x? Well, if we differentiate cosine x, we'll get negative sine x. So we don't want that. We don't want negative sine x, we want positive sine x. So we should move the negative over to the cosine x. So it'll be negative cosine of x. So equals negative cos x. But then, let's not forget, we have that plus c. So we're going to say f of x equals negative cosine x plus c, okay? Then we want to figure out what plus c is, though. In our case, we can do that, and we can only do that if something is given here. So we're going to have 0 equals negative cosine of 0 plus c. Well, negative cosine of 0 is negative 1, then plus c, and you just add and you get c equals 1. So we get our final function, f of x equals negative cosine of x plus 1. Okay? Thank you for watching. Let me know if I said anything wrong or if you have anything additional to add. Have a great day.